السلام عليكم ورحمة الله وبركاته والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. In this video, we'll talk about the integrated rate law. And we before talked about the differential rate law and what is the difference between the differential and the integrated rate law. Actually, the integrated rate law will give us exactly the relation between the concentration and the time. So it's express the concentration as a function of time. So we will study the concentration of the reactant with time and how the concentration will change with time and what is the relation of the function between both. And we will have different formulas, and these formula will be differ according to the order of the reaction. So it's not like the differential that you have only one formula, which is R equal to K times the concentration to the power of N, and this one N is called the order, and this one be 1 or 2 or 3 or 0. But here actually we have different formula, and these formula different formulas, and to determine the formula, first we need to determine the order of the reaction. Let's see the most common cases that we have. We have three cases here, which is the first and the second and 0. Okay, so what we have first, the rate law. Rate law, it means the differential rate law, and we know that rate law equals R equals to K, which is the constant times the concentration, and it's the first order here, so it means to the power of 1. And for the second order, it will be R equals to K times A to the power of 2, because it's first order. And 0 order, so R equals to K times a concentration of A to the power of 0. It means this one can be deleted, so it will be R equals to K. So what we can use, how can we use this differential law, or what is the information that we can use from this differential rate law? So for the first one here, for the first order, if we change the concentration by a factor, so the rate will increase by the same factor. It means that if you increased the concentration by 2, it means you will put 2A instead of A, so the rate will be 2R. So if you increase the rate or the concentration by a factor of 2 or 3 or 4, so the rate will increase by the same factor. And for the second order, if you increase the rate by a factor or the concentration by a factor, so the rate will increase by the factor, this factor squared. It means that if you increase A by 2, you know this one is squared, it means the rate will be increased by a factor of 4. And here for R equals to K, actually there is no concentration here. So if you change the concentration by a factor, it will not affect the rate because it's not included in the formula. Okay, so what about the integrated rate law? First, you need to know what order we are dealing with, because from the order, we will write the integrated rate law. So for the first order, the rate law is ln concentration of A equals to minus KT. K, we know this is the constant, and the T is time, plus ln the initial concentration of A. And if we try to draw this graph, we will draw ln A versus T. So this is T, and this is ln A. And we will get a straight line. So if it's first order, when you're trying to draw ln A, ln the concentration of A versus time, so you will get a straight line. And this straight line has a slope, and the slope will be equal to minus K. Okay, so what about ln the initial concentration? This is the intercept here. Okay, so first, when you know this one is the first order, so you can know the integrated formula, which is ln A equals to minus KT plus ln the initial concentration. Or if you have the graph, and if you draw the graph and you find that ln the concentration versus time will be a straight line, and this straight line with a negative slope, so this means that this reaction is a first order. And we can do the same for the second order here. So if you check the second order, we'll draw 1 over the concentration versus T. So this is 1 over the concentration, and this is T. And if we draw 1 over the concentration versus T, again, we will get a straight line, but this is straight line with a positive slope. So the slope here is a positive value, which is also K. And the K is always positive value. Okay, so the negative will be the slope, not K from here. Okay, so here, if we draw 1 over the concentration versus time, we will get a straight line, and this straight line with a positive slope, and the slope will be equals to K. And again, the intercept, it will be 1 over the initial concentration. And here for the 0 order, if we draw again here the concentration versus T, so we will get again a straight line, and this is straight line with a negative slope, which is equal to minus K. And the intercept here will be the initial concentration. So if you know the order, so you can write the formula, or if you know the graph, you can predict which order it will be. Okay, so for the first order, it will be ln K versus T, so it will be ln A equals minus KT plus ln the initial. For the second, it will be 1 over A equals to KT plus 1 over the initial. Oh, sorry, this one should be down here. And for the zero order, the concentration equals to minus KT plus the initial concentration. Okay, if you have the graph, so you can know the slope, or the slope will be K or minus K, and you can know the intercept, and the intercept is then the initial, or 1 over the initial, or the initial itself, according to the order. Again, so we can know or determine the half-life time. And again, the half-life time, it means the time that you can consume half the amount of the product, or sorry, of the reactant that you have in the reaction. So when you consume half the amount of the reactant, this will be called the half-life time. So this is the time that you are taking to consume half the amount of the reactant, called half-life time. And half-life time, actually, again, it will be different according to the order. So if it's a first order, so it will be 0.693 over K, which is ln A ln 2. And the half-life time for the second, it will be 1 over K times the initial concentration. And the half-life time for the zero will be equals to the initial over 2K. Okay, the last point, you can determine the unit of K. And the unit of K actually will be determined from the differential rate law, from R equals to K times the concentration of A. Okay, so if it's first order, so it will be second minus 1. If it's second order, it would be liters per mole second, or molar minus 1, second minus 1. If it's zero order, so it will be molar per second, or mole per liter second. Okay, let's see how to determine the order of the reaction. So we have a reaction here. Okay, so this is a reaction between NO2 and plus O2. Sorry, this one gives NO plus O2. Okay, so now we need to determine the order of this reaction. And he actually plots here 3 graphs. The first graph, ln the concentration over versus time, 1 over the concentration versus time, and the concentration versus time. So we will check which one of them will give us a straight line. So it seems this one, it's a curve, it's not a straight line. Right, so if this one was a straight line, it should be a zero order, but actually it's not. So it's not a zero order. Again, and we have another one here, and again this one is a curve, it's not a straight line. So this for the second, if it's 1 over the concentration versus time straight line, so this one will be a second order. It's not. We have only one straight line when we draw ln the concentration versus time, so this one is a first order. And to determine the K, we need to only calculate the slope, and the slope will be equals to minus K. And we have the intercept here, and the intercept is then the initial concentration. Let's see another one. So we have another graph here, and we have the graph with ln the concentration versus time, and 1 over the concentration versus time. This one, the first one, is not a straight line, so it's not a first order. For the second one, if you do 1 over the concentration versus time, it gives us a straight line. So this one is a second order. So if this one is a second order, it means that when we calculate the slope for this one, it will give us K. And the intercept here is 1 over the initial concentration. Okay, we have again another one. So here we need to check everyone. So this is the concentration versus time, and it seems this one is not a straight line. So it's not a zero order. Okay, this one 1 over the concentration. If it's a straight line, it means this one will be a second, but it seems that this one is not again a straight line, so it's not a second. But here for ln the concentration versus time, it's a straight line. So this one is a first order. And again, if you know it's a first order, it means ln the concentration equals to minus KT plus ln the initial concentration. So it means that from the slope, it will be minus K, and the intercept is ln the initial concentration. The last one. Okay, we have a reaction here between ln the concentration and also, sorry, graphs here. The first one is ln the concentration versus time, and it's not a straight line, so it's not a first order. okay? And here 1 over the concentration versus time, and this one is a straight line, so this one is a second order. And again, from the graph, so if you know that this one is second order, so the graph here will be equals to K, the slope. From the graph, you can determine the slope, and the slope equals to K, and this one will be 1 over the initial concentration.